Hi everyone. Today I will introduce you to the basic of TypeScript. And a few words about me. My name is Anna. I'm a lead engineer at Smartlie.io. I do full stack development, and I've been working with JavaScript for 7 years now, and 3 of those I've been working with TypeScript. What we'll talk about today is, first, I will tell you what TypeScript is, then why do you want to use TypeScript, how to use it, a few words about types, then cost and benefits of using TypeScript in your project, and a short summary. And in the end, you can ask questions, or you can also ask questions in the chat, and I'll read through them at the end of the presentation. Okay, let's begin. So firstly, what is TypeScript? According to TypeScript website, TypeScript is JavaScript with syntax for types. So a TypeScript is an open source development language developed by Microsoft and founded in 2012 by a C# architect. It's a superset of JavaScript, and it extends JavaScript by adding static typing and structuring. Browsers can't run TypeScript, but TypeScript is transpiled into perfect JavaScript. And you can use TypeScript like you would use JavaScript. So for example, in a front-end application or in an Node.js application. Now, why do you want to use TypeScript? There are several reasons why TypeScript is great. Firstly, it catches the mistakes in your code earlier on. It supports JavaScript libraries and API documentation. Static typing structures and documents your code. It makes your code easier to maintain. And it makes it easier for you to use frameworks and libraries. And I'll go into a little bit of detail about all of these points now. So firstly, TypeScript catches mistakes in your code earlier on, before you have had a chance to run your code. And problem descriptions in TypeScript are usually better than what you would get from the JavaScript engine. For example, how many times have you seen undefined is not a function? TypeScript usually tries to be a lot more helpful with its errors. Then secondly, TypeScript supports JavaScript libraries and API documentation. So you can keep using all the same JavaScript libraries, even if they are written in JavaScript instead of TypeScript. You don't have to make any changes to the libraries you use in your existing project if you want to introduce TypeScript. Static typing structures and documents your code. It makes it easier for other people to understand what your code is doing if your code has types. It makes your code easier to maintain. TypeScript will make it harder to accidentally break existing functionality when you're making changes to the code. Unfortunately, while it makes it harder, it's not impossible. And TypeScript make it easier to use frameworks and libraries because you will get better autocompletion for imports. And TypeScript should call you out if you're trying to use some external function in the wrong way. This is especially true for frameworks and libraries that are written in TypeScript, but it also works to some extent with JavaScript libraries. So here's an example of how TypeScript can be useful. Do you see the problem in this code? So here we have a function that accepts an argument called name and then calls to uppercase function on it. And we are trying to pass in number 2020 to this function. TypeScript can tell us that this is wrong by giving hints. It sees that to uppercase is a string method, and we are trying to call to uppercase on an integer. So we can fix this function by typing it correctly. So now we're telling that this name to uppercase function accepts an argument of type string, and it returns a string. So when we try to call it with an integer value, TypeScript will tell us that this is wrong, and we will see this error in the editor even before the code is run. And here's another example of the kind of typo that I myself have made countless times. Can you spot the problem here? TypeScript would, and it would tell you instantly. So as you can see, we have an array of names here, and we're mapping over the array. We're getting each name, but then instead of using the name in the string, we're actually trying to call to uppercase on the whole array. And this is kind of difficult for the user, for the programmer to spot, but TypeScript would instantly tell us that this is not something that we can do. Now, how do you use TypeScript? You have two options here. The first one is to install the npm package of TypeScript, create a tsconfig.json file with a configuration, and set up the compiler. The second option is to choose TypeScript at setup of your favorite framework. And most frameworks already have this feature. For example, when you create a React app with a create React app, you can choose to use TypeScript. Now, about types in TypeScript. JavaScript has 6 principal types. We have a string, number, undefined, null, symbol, and Boolean. All the other types are called objects. TypeScript has all the types from JavaScript and a few extra types. The extra types are void, tuple, enum, null and undefined, never, and any. Let's start with void. Void is the absence of having any type at all. In TypeScript, you have to define the return value in your functions. But there are functions which don't return anything, and they don't have a return statement. So here, void comes into play. To define the return type, you can add colon and the type after the function parameters in brackets, like this. So here our name to uppercase function has a return type of string. You can also use it with a one-liner function. Now, what if we don't return anything? We have this log name to uppercase function, and we state that it accepts a string and return a string. But in fact, the function just console logs something, and it does not have a return statement. So in this case, TypeScript will show us an error saying that a function whose declared type is neither void nor any must return a value. So in this case, we need to use void type to explicitly say that the function does not return anything. So now this function is correct from TypeScript perspective. We state that it returns a void, and indeed it does not have a return statement. Then we have tuple. Tuples are organized arrays with predefined types per index. This array has a specific order, but the size is not fixed, and it can have different types inside. Here's an example. We have tuple where the first element of the array is a string, second one is a number, and then two more strings. And we assign a value where we have a string, number, and two strings. Note that as always in TypeScript, when you don't follow the rules you set with the type, like the order in this case, TypeScript will give you a hint or an error telling you what you did wrong. For example, type string is not assignable to type number. So this is what will happen if you try to put a number in, let's say, the first element in this example. Then we have a type enum or enumeration. It's a set of constants, but with more friendly names given to them that you can use. So for example, we have a enum with different app states. And you can also manually set the values to the enum values if you need more specific results. Like here, we have an enum called color num, where each color is assigned a number. And then when we reference color num.red, for example, we will get 1. And similarly, we have color, where colors are assigned letters. And when you reference color.red, you will get R. We have null and undefined. They are usually used with other types, like number, when the value might be missing. Null can be assigned to the variable, and it indicates the absence of any value. Undefined is present when the variable has been declared, but has not yet been assigned a value. So there's not much going on when null and undefined are used on their own. Here we just have a variable with an undefined value and a variable with a null value. Null and undefined are very useful when used in a union with another type. For example, if we are waiting for a request and haven't received the data yet. Here we have my string value, and it can be either a string or a null. And we start by assigning a null to it. And then we wait for some long request, and eventually we assign to a string to the same value. When you have a union type, you will have to add extra checks for TypeScript to narrow down the type to a specific one. So continuing from the previous example, we had a myString value that can be either a string or a null. So if we now try to call toUpperCase on this variable, TypeScript will not be happy because it knows that this value might be a string, but it might also be null. So if we add a check here, where we verify that the value is not null, TypeScript will once again be happy, and it will let us use all the string string functions on this variable. We have a type called never, and this represents the type of values that never occur. This is mostly used in error handling. For example, we always expect the data to be fetched from an API, but if we cannot fetch it, we need to handle the error. So here we have a handle error function, and it returns never because we expect this to never happen. We have a type any. When you don't know what type you're dealing with, or you are in a situation where you cannot explicitly define the type, you could use the any type. Here we have a variable called not sure of type any. We start by assigning it a number, then we assign it a string, and then we assign it a Boolean. Note that any provides an easy way to actually avoid type checking. So be careful when you use this, because with any, you cannot be sure of the type. This means TypeScript safeguards will not work. Any might be useful if you don't know the types in an external library, or if you make use of an existing JavaScript functionality that is not typed yet. So in this code example, because the variable is of type any, we could call any functions on it. For example, we could call to uppercase on it, even though it's a Boolean. And TypeScript would not tell us it is wrong, but we would still get a JavaScript error when we try to run the code. So those were the basic types, but we're not there yet. There's a few more extras. We have type assertions. It's a way to tell the compiler to trust you. Type assertions are useful when you know the type of some entity could be more specific than the current type. For example, we have a variable called anything of type any, but we see that it actually has a string value. So we can create a new variable and assert that it is a string. We can do this with angular brackets, or we can do this with as keyword. And type assertions are especially useful for telling the compiler the type of data you expect to get from an API call or an external untyped library. For example, let's say we have a get username function that we do not have types for, but we know that it should return a string. So we can tell the compiler that it should treat it as a string, and now we can call to uppercase on it. We have literal types. You can use a string literal as a type. So you have a variable called foo, and the type is string literal hello. Now you cannot assign anything else to the string except hello. Combining string literals with a type union is a powerful and useful abstraction. So in this example, we have type direction, which can either be up, down, left, or right. And we have a function called move, which accepts distance, which is a number, and a direction of type direction. So now we can call this function with values 1 and up, But if we try to call it with values 1 and under, TypeScript will tell us that type under is not assignable to type direction because it is not one of the valid directions we have specified here. You can also use Boolean and a number as a literal types, like this. Here, type 1 to 5 contains numbers from 1 to 5. Type bools contains values true and false. And type nums and bools can be either 1, 2, or false. Then we have interfaces. Interfaces are a way of naming particular types. It's basically a group of related methods and properties that describe an object. All right, here's an example usage of an interface. We have an interface called person, and it has 3 properties. First name and last name are of type string, and age is of type number. Properties in an interface can be set optional with a question mark after the property name. So here we have an interface person where first name and last name are required properties and email is optional. So it could be specified and it could not be specified. Interfaces can extend each other. This allows you to avoid code repetition. So continuing with the person example, we can extend interface person and create a new interface called user, which will get all the properties from person and also an email property. So now if we try to create a user object without specifying the email, then TypeScript will tell us that email is required in the type user, but is missing in the object we were trying to create. We have arrays, array types. You can type something as an array of X with either square brackets or the array keyword. And this works with any type, including interfaces. In this example, we have an array of strings called names. Then we have more names, which is also an array of strings, but it uses the array keyword. And then we have an array of interface called person. We have functions. It can be useful to type a function, for example, when expecting a callback with a specific function signature. For example, we could have an onChange callback, and we create a type for it. So the onChange callback would have one argument of type string, and it would not return anything. You can use read-only to prevent errors from mutating objects. When an array or a tuple is marked as read-only, TypeScript will throw an error when you try to add, remove, or update items in those objects. And this is especially helpful in functional programming to avoid side effects. So here we have a regular array of strings, or we have a read-only array of strings. It can be specified either with the read-only keyword or using read-only array and angular brackets. We have type unknown. and you should prefer unknown over any to get better type safety. Because using any can be a useful escape hatch, but there are also good reasons to avoid it. It doesn't guarantee any type safety, and it hides errors from the consumer up the call chain. With unknown type, TypeScript will correctly surface errors, such as calling non-existing methods. Here, for example, you have any data of type any, and if you try to call a non-existing method on it, you will get no errors during compiling, but you will get those errors during runtime. Now, if we type this data as unknown and we try to call the non-existing method, TypeScript will tell us that this is a problem. Now about TypeScript errors. Although TypeScript tries to make the error messages as helpful as possible, this could lead to an overload of information thrown at you that you might not really understand how to interpret. Let's look a bit closer at the different types of errors to help you understand them. There are two different types of errors you can get, short errors and detailed errors. Short errors, this will provide you an example conventional description of the error with a message. Here's an example. Argument of type foo number bar function that returns a string is not assignable to parameter of type something complex. Then we have detailed errors. Most of the time we need some more information on why the error is happening, and that's why there are detailed error messages. Here's an example of the previous error in a detailed format. And here you can see there's a bit more information. And the detailed error will provide you with a chain of things that happened. And the previous error should read like this. So first we see argument of type something is not assignable to parameter of type something complex. Then we have an explanation because types of property bar are incompatible. And we have an explanation to that. Type function returns a string is not assignable to type string. The errors provided by TypeScript should help fix your bugs. And you can always use the TS some number error code in the short error to find other similar cases online to help you out if needed. Now, there are costs and benefits of using TypeScript in your project. The costs are setup time and initial training, because when you start adding TypeScript to your project, it will take some time to configure, and it will take some time to learn to use TypeScript and to use types. There is also the typing overhead, because every time you write code, you will also have to write the types, and it will take a bit of extra time. Then we get to the benefits. So firstly, developer tooling. You get hints from TypeScript. You get better error messages, and you get error messages earlier, and you get autocompletion for everything that has types. Then we have refactoring effort. When you're trying to refactor your code, it's very easy to break everything. TypeScript helps a lot here, because if your code is typed, then you would see all the errors that were created by the refactoring without even having to run the code. And usually in the refactoring effort, as soon as you get rid of all the TypeScript errors in your editor, you are already done and your code will most likely work. We have type safety. It's complementary with code reviews and unit tests. It adds a guarantee that your code will work. Code documentation and readability. It's a lot easier to understand the code that has types. It will help other people working on your code base, and it will probably help you if you revisit the code at a later date. Type annotations can be optional. So if you don't want to type the whole project when you add TypeScript, you don't have to. You can start small and you can do it in steps. And the last benefit is recruitment, because some developers refuse to work without types. And summary. TypeScript is a superset of JavaScript. It is JavaScript with added superpowers. TypeScript is transpiled into JavaScript. When you start using TypeScript, you use a TypeScript compiler, which will convert your TypeScript into normal JavaScript, and you can run that JavaScript as normally in the browser or as an Node.js application. TypeScript catches mistakes in your code early on. You can see that you have a problem before you run your code and before you've spent time potentially transpiling, compiling, going through the flow of your application. It saves you a lot of time. And static type checking is amazing. It saves a lot of time and it saves a lot of headache. To add TypeScript to your project, to use TypeScript, you add it to your existing projects, and your projects will keep working even before you have added types everywhere in your code. Then you can start adding types. Here are some useful links. We have official TypeScript documentation. We have a TypeScript deep dive and a list of more TypeScript resources. Thank you. Now, do we have any questions?
We have one question, and okay, I will read it. I've heard that you should be careful when using oh, sorry, English isn't my strongest skill, so assertions.
Yep, as assertions.
Yep. Yeah, and type quirks are better. I'm not really sure why it would be so. What's your opinion on that?
So with as assertions, you're basically telling the TypeScript compiler that the type of this value is going to be X. For example, the type of this value is a string. Now, if you're sure that it is a string, then it's not a problem. But if you cannot be sure, for example, you don't know where the value is coming from, then you can use type guards to actually check if it's a string or not. And then if it's not, then you can handle that situation in some specific way, like maybe show some kind of error or depending on your use case.
Okay. Can you see those questions in our chat, or will I read those? Next
Yeah.
one is,
Yeah, I can go from the top.
Okay, thank you.
Well, I'm not going to answer about the recording. I understand that it's available, but Sanna knows better, or it's actually already answered. There's a link to the recording, and the slides will also be added there. Should you use React prop types or TypeScript when doing React projects? You can use either, but it's more natural to use TypeScript in a TypeScript project, and React, it will work the same way as React prop types. So you will get all of the benefits. Yes, you can use prop types, but I would recommend using TypeScript types. Do we have any other questions? And I can just comment that from my own experience, I've been using JavaScript for a few years now, but once I started using TypeScript with JavaScript, there's no going back. It's just too good. There is really no reason to use JavaScript without types any longer.
If that didn't convince the audience, I don't know what will. But I guess we still have some time. So if you have any last questions, take the time now. And otherwise, I think there's no need to hang out in the meeting if no one has anything to add.
So we have a question. Do we use TypeScript in both front and backend side? Yes, in Smartlie, we use mostly React on the front end, and it's all TypeScript. And on the backend, we use a lot of Node.js, and it's also all TypeScript. In fact, we enforce types. So like I said before, you don't have to add all of your types when you first start with TypeScript. But at Smartlie, we have a certain linting rules for our code, which forces us to use types. So you are not allowed to write any code that doesn't have types. And there is a good reason for that. We do not want things to break. It's very important for us that things work. So we make sure that types are added from the beginning. As for how long would I say it takes to learn? Well, it depends if you've used other type languages before. It's a bit easier if you have, like let's say you've coded in Java before. It's maybe will take a bit longer if you haven't, but TypeScript is pretty easy. If you work with basic types like interfaces and arrays and numbers and strings, it's very, very straightforward. And you would pick it up in in a very short amount of time if you already know JavaScript. Of course, it also has many more complicated things that I didn't go over here. And to master those, well, it would take a long time, but you don't usually need to go into the specifics. Can I think of any situation when using only JavaScript and not TypeScript would be a better idea? I would say that only, well, I can think of two situations. One is if for some reason I don't have, I cannot transpile my TypeScript. So let's say I'm writing some code straight into DevTools console, and that does not support TypeScript. So I would have to write JavaScript there. But usually that's not a common situation. A second case is if I need to prototype something really fast, like I'm very time constrained, and I'm also sure that the prototype is not going to be developed further. Because if it were, then I would still need to add types at some point when it becomes a real application. But if I'm sure that this is something I'm going to do for 2 hours and then throw it away, so there's no need to ever maintain it, then I could go with plain JavaScript just to make it a bit faster. And would it be better to focus on TypeScript than JavaScript? I'd say it's better to focus on TypeScript because if you learn TypeScript, you will also learn JavaScript. But it will give you more opportunities if you know TypeScript. Something about Smartlie.io. Well, I can say that it's a great place to work. And every now and then we have a Launchpad program. Maybe Tina can tell more. But basically, it's an internship program for developers who are starting their career.
Yes, and unfortunately, we have just closed the kind of application period for this summer, but you can stay tuned to apply later on, and I can link the landing page on the chat as well, so you can take a look at that.
Tips on where to learn TypeScript, courses online that are good for junior developers. So firstly, there is a course in Helsinki University. It's called Full Stack Open, and they actually teach you many other things, not just TypeScript. They teach you the whole TypeScript web development stack. It's a very long course, but it's very useful. If you're interested in just TypeScript, what I personally like is Code Wars. Code Wars is a set of like small coding exercises, and they start with beginner ones. So you have to solve some very simple coding problem, and once you've solved it, they also show you how other people solved it. So you can see if maybe there was a better solution than what you came up with. The name of the course is Full Stack Open. I think if you just Google that. But yeah, there are other sites. There's Udemy, and then there is Code School. They also have courses that start at the very beginning. So in Visual Studio, when starting or doing a project using C#, the compiler says using TypeScript 4.6. Does that mean that the compiler uses it, or what does it mean? I'm not actually sure if it's a C# project. Yeah, sorry, I can't answer that. Yeah, there are some very good tips in the chat on where to learn TypeScript and maybe other languages as well. Plays just for TypeScript. I'm not sure. I mentioned Code Wars. It also has, here's a link. It also has other languages, not just TypeScript, but they have like these very small exercises in one specific language. And they can be very easy, like things that will take 5-10 minutes. And then they have more difficult ones. Just to clarify, JavaScript is backend, but I've seen TypeScript mentioned among front-end skills too. How is that? Both JavaScript and TypeScript can be used for backend, for writing Node.js applications, and for front-end, in which case they run in the browser. So on front-end, JavaScript and TypeScript can be used with, for example, React or Angular or Vue or something else. I'm glad this is useful. I hope more people can learn to enjoy types. Okay.
Many thanks for me to you. And let's have a great weekend.
Thanks everybody for listening.